Friends, good evening. Today I am going to take up the story about the cloudbursts and the reason behind it. Cloudbursts are very common in the mountainous regions in the Himalayas, and it is also common nowadays inland, that is the coastal regions. In Mumbai 2005, there has been a cloudburst which had claimed lots of lives. Around 94 millimeter of rainfall in 1 hour had affected the lives of many people in Mumbai in 2005. I have referred to different articles in different newspapers and the Encyclopedia Britannica too to understand this cloudburst. While I am referring to the Science and Technology column of September 11, 2022 in the Hindu, it is not only explaining about the cloudbursts, it is also explaining why the cloudbursts are not predictable now and cannot be monitored now. What is the difficulty in monitoring and forecasting the cloudbursts? So many newspapers and so many magazines have explained about this cloudburst because it is very common now in India. The Times of India jokingly starts the article explaining the cloudburst of Telangana by taking the quote from Chandrasekhara Rao, the Chief Minister of Telangana. He reacted to the cloudburst in Telangana by saying that it was a controversy. Earlier, only Himalayas, that is the Jammu Kashmir and Uttarakhand, had cloudbursts. Now it has moved to the southern region of the India. This is a controversy, is what K. Chandrasekhar Rao, the Telangana Chief Minister, had reacted to the cloudburst in Telangana. Whether this is true or not, let us see. It is not true. This is not a kind of conspiracy. It is because of the climate change. The climate change makes air warmer. This warmer air can hold more moisture, and when this moisture, 1 degree centigrade increase in the temperature has occurred in India and all over the world because of the climate change. And with this increase in the temperature of the climate, the air gets more and more moisture content. And with this more and more moisture content, the air holding moisture forms a situation which I am going to explain, where the cloudbursts are occurring all over the nation. Friends, this is known as Clapeyron relationship. What is Clapeyron relationship, my dear friends? This is the climate change induced temperature, that is 1 degree centigrade increase in the temperature, which is causing the air to contain more moisture and then the resultant cloudburst. This is closest Clapeyron relationship. Friends, due to this closest Clapeyron relationship is what we are able to see more frequent cloudbursts now in India. Recently, Dehradun had witnessed one big cloudburst, and in Uttarakhand, the Kali River witnessed one big cloudburst, and many parts of India, like it was reported that the Amarnath shrine, that way towards Amarnath shrine, also witnessed greater cloudburst. However, it was later proved that it was not a cloudburst. So these are the news items I have taken from Times of India, and I have referred to the Outlook, the Indian Express, of course the Hindu, the Encyclopedia Britannica, and the India Today to understand the reason behind this cloudburst and why we are not able to monitor and forecast the cloudburst. Cloudbursts are defined by the Hindu. Also, it is defined in the Times of India, that is the Times of India explainer, and the India Today explainer, the Outlook explainer, the Encyclopedia Britannica explainer. More apt definition is given by the Hindu Science and Technology column. It is given like this: the adjective is a violent, and voluminous. Violent, both violent and voluminous. Fall of water in a short span of time within a few area. That is, it is occurring within a area of 10 to 50 square kilometers. Most of the newspapers have fixed the area of occurrence of cloudbursts as ranging between 16 or 20 to 50 square kilometers. The Times of India supports this. The Hindu supports this. Times of India is saying 10 to 50 square kilometers. The Hindu is saying 20 to 40 square kilometers. So, in this a very small area, a very huge quantity of rainfall and violent and voluminous quantity of rainfall in a short span of time, if it is occurring, that is called cloudburst. The Amarnath shrine incident was not a cloudburst. Why this is not a cloudburst? The way to Amarnath shrine was was inundated with heavy rainfall. However, it is not a cloudburst. Why it is so? Because there is a criteria fixing the definition of cloudburst. How we can say that a cloudburst has occurred? The Indian Meteorological Department estimates that for a rainfall to call as a cloudburst, there should be 100 millimeter of rainfall in just 1 hour. Hindu is saying this. In most of the newspapers, it is given that 10 centimeter of rainfall in 1 hour. And in the Indian Express explainer, it is given that even half an hour, a 5 centimeter rainfall is called as a cloudburst. So, Indian Meteorological Department has also issued an explainer in their website saying that 10 centimeter of rainfall in just 1 hour is the cloudburst. Significantly, I am drawing your attention to the Encyclopedia Britannica, which has said that, as supported by the Hindu says that in the mid 19th century, the cloudburst has been in existence. The Encyclopedia Britannica is giving two examples where the cloudburst had occurred in 20th century. The first one was in Panama, that is 2.5 inches of rainfall in just 3 minutes. That was in 1911. That was the first occurrence of cloudburst as per Encyclopedia Britannica. And thereafter, in 2000, in 1970, there was a cloudburst in France. There was a cloudburst in France that was 1.5 centimeters in just 1 minute. So huge cloudbursts had very rare occurrences all over the world in 19th century and 20th century. But now, down the 21st century, by 2022, the cloudburst phenomena has become very, very often and very, very frequent. As reported by the Outlook, the India Today, the Indian Express, the Times of India, the Hindu, the Encyclopedia Britannica, the Outlook, all have explained that the cloudbursts are very frequent now in India. The Times of India reports, I have told you, the Kali River, the Tamasa River, all these rivers have faced the cloudburst. So, what is the reason for this cloudburst? In geography, this is called as orographic effect. What is that orographic effect? That is when the southwest monsoon in South India, how this cloudburst is occurring when the southwest monsoon is reaching the inland of Telangana and Maharashtra and the southern regions. What happens is that it starts ascending when the southwest monsoon, that is monsoon winds, are ascending the hills. It reaches the stratosphere. The Hindu says that it reaches the stratosphere. Stratosphere is extending up to 20 kilometers, 21 kilometers up to the Earth's atmosphere. So it reaches the 12 or 15 kilometers in height and reaches the altitude of the mountain. So the Hindu explains that because of this orographic effect, the winds, that is the monsoon winds, the southwest monsoon winds, especially in the Western Ghats, it ascends to the top of the hill, and when it reaches 12 to 15 kilometers, it it reaches the altitude of the hill, remaining within the stratosphere, it forms the warm temperature of the winds escape and it forms clouds. How these clouds are formed? When the gases or the air which is moving upwards and has reached the altitude loses the warmness or the temperature, the attractiveness between the molecules of the air increases, so it condenses. I have referred to the Encyclopedia Britannica. It explains the condensing phenomenon like this: when the temperature of the air is lost, when the temperature of the air is lost or the wind is lost, what happens is that the attractiveness between the air molecules increases and it comes together and condenses and forms water droplets. And these water droplets are converted into 1 kilometer length of cumulonimbus clouds. Cumulonimbus clouds, my dear friends, remember this is a fluffy shaped, very white shaped cloud and it is full of condensed water. And how the cloudbursts occur, my dear friends, when the rainfall from the cumulonimbus clouds are hitting the ground from the mountainous altitude, from the altitude when it comes down and when it is trying to hit the ground, more wind is keeping it upwards. More wind pushes it from the below and keeps it upwards, and it accumulates and it accumulates again because the wind from the below is trying to push it upwards and it accumulates, and it cannot rain towards the valley of the hill and it accumulates there and it rains, and when it rains and water accumulation comes to such a very huge level and it becomes dense and it cannot hold it anymore because the winds which are blowing from below is carrying it to the altitude of the mountain where it accumulates and becomes denser and heavier and it cannot hold it anymore and just falls in a very huge roars violent way, and this is how the cloud bursts are formed, my dear friends. That is, the accumulated water falls or just hits the ground in a very violent fashion, which is what cloudbursts are all about, my dear friends. And this is what causes the loss of lives and the floods and economic loss also. Crores and worth of economic losses it is causing, and the lives are also being lost. So this is cloudburst. However, the prediction of cloudburst is not possible. Why? The Outlook has reported that, and also in the India Today there is a report that the Hindu has taken up the topic. That is the topic of the science and technology column today. Why the cloudburst cannot be forecast or cannot be measured or cannot be measured. So what is the reason? How we are not able to monitor? It cannot be monitored. What is the reason? Because the satellites are helpful, but what happens is that the precipitation phase of the satellites do not have that much resolution to forecast the or monitor the cloud bursts. And what happens is that the resolution, high resolution cameras or high resolution equipments are required to capture or monitor the cloudburst. It is occurring in such a heavy and speedy way that it is not possible to capture this cloudburst. However, there is a Doppler radar, that is a Doppler radar which is located in 7 regions in the Himalayas, which has been explained by the Ministry of Earth Sciences in the Parliament in July. The Ministry of Earth Sciences, while replying to question about cloudbursts in the Parliament in July 2022, has explained that 7 Doppler radars are located in the Himalayas, 2 in the Jammu Kashmir, 2 in the Uttarakhand, 1 in the Meghalaya, 1 in Assam, and 1 in Tripura. So 7 are there. What happens is that this uses the Doppler radar is using a Doppler effect, the microwave radiation, that is microwave radiation, the reflection of the radiation, it sends the microwaves, and the movement of the clouds are observed by the getting the reflection from the location where this cloudburst is going to occur. So this is the Doppler effect which is being made use, but it is very expensive. Hence, what happens is that it is not very much, cannot be deployed everywhere around India. However, we have to keep it in mind that this has to be reduced and this danger has to be contained in the present form. However, we are trying to make or allocate, because even sometimes it has been seen that 20 lives have also been lost. So this has to be arrested or this has to be stopped. Friends, I hope you understood what is a cloud burst and how it is formed, where and all have it occurred, and how frequent it is today, and how it is not possible to monitor and focus the cloud burst by the Indian Meteorological Department today because of economic reasons and the low resolution of the satellite facilities which we have today. Hope it improves in future, so that this one lacuna can be just caught beforehand, so that nowcast means within hours of the occurrence of the hours before the occurrence of the rainfall, the nowcast will be possible in future. Friends, I am signing out today. Meet you tomorrow. Bye.